we are finding the integral of a product ex times cosine x. For that we use the formula called integration by parts, which is here. Let me write integration of u with respect to v, u dv equals u times v minus v du. Okay, so we will match our question to the left side and we get right hand side from this formula. So we need to choose u and dv. So let's say this to be our u and this to be our dv. Generally we choose u whose derivative whose derivative is simpler than the original. So ex, what is the derivative of ex? Ex. Okay, it does not change. And we choose dv part so that when we can easily integrate. So what is the antiderivative of cosine x? That's sine x. Okay, so it doesn't matter in this case because both are not vanishing. When we take the derivative of ex, we get ex all the time. When we integrate cosine x, it becomes sine x, again cosine x, sine x. Even if we switch, say u to be cosine x, then the derivative will be sine x. So in this case, choosing u and dv does not matter. I'll show you both. Okay, let's go for this now. So let u be ex and dv be cosine x dx. Let's find the derivative du. Du is ex, is just ex with respect to x. Find the antiderivative. So v equals sine x, and using the formula always ub minus v du. Okay, then I want to say the whole question is I, integral I equals, using this formula, u v, which is ex sine x, u v minus v du. V is sine x times ex dx. So the question, original question, equals ex sine x. This part is settled down. We still have a product of two functions, sine x and ex. Okay, then we have to go for integration by parts one more time. So we need to find new u and dv. So in this, for this part, just for this part, okay, we have to go for u and dv. Let me do over here. So u be sine x. If you do that, then you are not gonna get the answer. So you have to be consistent, because we started u to be ex, so ex should be u again. Okay, so u to be ex and dv is the remaining. So let me write over here. So u to be ex and dv is remaining, which is sine x dx. Okay, sine x dx, and we find du. So du is just ex dx, and v, so antiderivative of sine x is negative cosine x. Okay, then this, using this integral, using the integration by parts, negative here, so I'm going to put a bracket now, uv minus integral of v du. So uv means ex times negative cosine x. So negative ex cosine x uv minus integral of v du. So v is negative cosine x, negative, so makes positive cosine x ex dx. Let me get rid of this bracket. So the original question, original integral I equals ex sine x minus plus ex cosine x minus plus minus, and we have cosine x ex. So integral of, let me write ex in the first place, ex cosine x dx. again a product of two functions, but this is the same question we began with. Okay, so the whole thing is our original integral, and I'm saying that is I, so this is negative I, same original question. Now I can take this all the way to the left side, so negative I, when we take to the other side, I plus I 2I, and I can write down plus C now because we need a constant here. Let's say plus C1 for now. Okay, let's move this to the left side, negative I and here's I, so it becomes I plus I 2I, two integrals in fact, equals ex sine x plus ex cosine x, this part is gone, plus a constant, any constant C1 to finish this problem, because we need to find just I, so divide by 2, so I equals divide by 2, so 1/2 ex sine x plus 1/2 ex cosine x plus 1/2 C1, so I can just say a new constant C. Okay, this is the final. Let me do this problem by assuming u and dv in different way. Let's go back to the question, so let me erase everything now and try in alternative way, and we are supposed to get the same answer. Okay, so let me finish erasing this. Now if we go back, we were saying u to be ex. Now I want to show it, so let me write in this way. Let me rewrite the question. Our integral is cosine x ex dx. In this case, this is u and remaining as dv. Okay, so let u be cosine x and dv be ex dx. So du, the derivative of cosine is negative sine with respect to x, and antiderivative of v is just antiderivative of ex is just ex. Then let's say this is the original question, so integral I, so I equals, I mean basically this integral equals, by this formula, u v minus integral v du. So u v, which is ex cosine x, u v minus integral of v du. So v is ex times negative sine x, this negative, pull that all the way, plus sine x dx. Now we have another product and we need to do the same thing as before. So this is our u. Make sure, hold on, u is cosine x, a trig function, so in this case this should be u is sine x, and the remaining, okay, ex dx, that to be dv. So for this part, u is sine x and dv be ex dx. So let's find du. So du, derivative of sine x is cosine x with respect to x, and antiderivative v is ex. So the original integral I equals ex cosine x plus, now let's use the integration by parts formula because we chose u and dv. So u v, u times v, I don't have to put bracket here because I'm working with plus sign unlike last time. So u v, so sine x ex, so plus ex sine x u v minus integral of v du, so ex cosine x dx. Okay, but this is the original question we began with, ex cosine x, so we can say this is the same integral I'm working with. So I, and we need to move this to the left side, and we get always a constant, let's say c1. Okay, and now let me erase the leftover from last time. Okay, this minus I, move all the way to the left side, I, this minus I plus I, so 2I equals ex cosine x plus ex sine x plus c1. And to finish this problem, divide by 2, so that the integral, the original integral, is divide by 2, so we get half ex cosine x plus half ex sine x plus half c1. Let's name that as c. That's the final, which is same as previous answer. In the previous answer we had this term in the front.